Hi, and welcome back to our series on the Hasura Python Lambda connector. So far, we've seen how to set up the Hasura Python Lambda connector, and we've talked about some of its capabilities. In this video, we're going to talk about how to use the powerful Hasura engine to perform joins from data to functions, functions to data, and even functions to other functions. The first thing we're going to want to do is get rid of the default functions. Start by clearing out the function code, and then we'll also delete the HTML files for the different functions. We're going to add a Postgres connector to our graph that we can create a join from. And one of the tables in the Postgres database we'll connect to contains coupons. And these coupons have an expiration date field. It would be nice if there was an isExpired field that was a Boolean that would return true if the expiration date has passed and false otherwise. We can actually write a function that we can join to that will handle this. We'll start by importing the datetime library, and then we'll use the register query decorator to wrap a function which we'll call isExpired, which takes as a parameter a string and returns a Boolean. We will try to use the datetime library to parse the timestamp. And we'll also get the current time and we'll return if the expiration date is less than the current time. We'll accept a value error, and if we get that error, it means the datetime failed to parse, so we'll raise an unprocessable content error with the message of the timestamp is not a valid datetime. And we'll also pass along some details where we will just pass the error message to make it easier on the user. Next, we'll want to perform introspection and add this new function to the graph. So we'll go to our terminal, and inside of the DDN directory, we're going to run DDN connector introspect Python. When the introspection completes, the next thing that we want to do is run DDN connector link add resources Python. Last, we'll need to do a supergraph build, so we will do DDN supergraph build local. And then if you're not running your engine, you're going to want to go ahead and restart it. Once engine is up and running, we can go to our console and we can now call this function by using app is expired and pass it a timestamp. And if the timestamp is in the past, in this case, I set the timestamp to the current time, it will say that it is expired. If we put it in the future, say tomorrow, then it will say is expired is false. Next, let's add a Postgres connector. So let's go back to our terminal and let's create a new terminal now. And we will go into the DDN directory. And from there, we will say DDN connector init postgres-i. And we will select the Postgres connector. We'll leave everything as the default, and we'll use the docs sample database. Next, we'll run DDN connector introspect Postgres. When the introspection's done, we'll add the connector link using DDN connector link, add resources, Postgres. And then we can do a DDN supergraph build local. And if we go to our console, we should be able to see all of the different Postgres models, which we've now pulled in, including the coupons that we had mentioned, which has the is or expiration date field that we're going to use for a join. So let's go ahead and set up our first join now, and we'll do that inside the isExpiredHTML file, which can be located inside the metadata directory. So we'll open that file and we'll go to the very bottom, and what we want to do is we want to add a relationship. So the kind will be a relationship, in this case to a command. We will name the relationship isCouponExpired, and for the source type, it will be the coupons model, and the target will be the isExpired command. And what we want to do is map the expiration date field to the timestamp field. And so I'll save that, and then I want to do a DDN supergraph build local. Now I want to go to my other terminal, and we want to stop our Docker containers, and then we want to restart it since we've recently added the Postgres connector. So we want to make sure that is turned on. Once the engine is back up and running, we can go to the console and we can construct a query, and we can query the coupons table. And as you can see, we can get the ID, the expiration date, and now there is another field, is coupon expired. And when we run that, it will go ahead and call our function and pass the expiration date as a parameter. And we can see this when we go into the Explorer and we look at the visualizer here. We can see this is expired is connected to the coupons model in the Postgres connector because there's now a relationship between the two. This is a good time to talk about parallel execution. For a simple function like this, there isn't any asynchronous I/O happening, but what if there was? What would happen if there was a network call that took 1 second inside this function? We can simulate this by making the function asynchronous and performing a 1 second sleep. If you save the file and then go to the console and we run the query now, it'll take 5 seconds, which is probably not the behavior that we want. But if we go back to the code and we go to the decorator and add the parameter for parallel degree and set that equal to, let's say, 5 and save the code. Now, if we go back to the console and we execute this, it will take about 1 second because it will execute up to 5 at a time in parallel. This is really powerful, but we don't need this function to be asynchronous or able to run in parallel. So we'll get rid of these for now. That's how you can add a relationship from a model to a command. Now let's talk about how you can add a relationship from a command to a model. The Postgres connector we've added, which is linked to the docs sample app database, has a table in it called orders. In this table, there is a status field, which will be set to either processing or complete. Imagine we wanted a function where we passed it a list of statuses and it would return the orders that had those statuses. Let's go ahead and create this function. Let's go to the Python code, and we're going to want to perform a join on the status field. So we need to make sure that the response is an object type with a status attribute. And we're going to want to register a new query. We'll call it get orders by status. It will take a array of strings, which will be the statuses, and it will return a list of order response. And we will just say return order response status equals status for status and statuses. Save the file, and then we'll go to our terminal and perform introspection. DDN connector introspect Python. And when the introspection's done, we'll run DDN connector link add resources Python. Now, before we perform a supergraph build, let's add our relationship. So we want to open the new get orders by status HTML file in the metadata directory, and we'll scroll to the bottom, and we want to define our relationship. We'll add kind relationship, and this time it's going to be a relationship to a model. We will name it orders by status. The source type will be get orders by status result array, which is the object type in the top of this HTML file. And then the name of the model that is the target will be orders, since we are joining to the orders. And the relationship type is an array in this case, since the response can be more than one order. And we want to map from the status field in the source to the status field in the model. And we'll save this HTML file, and we'll run DDN supergraph build local. And now we can go to the console, and as you can see, we can call the get order by status function, and we can pass it an array of statuses, and it will return an array of the order response object, which has the status, as well as all of the orders that have that status. And what's especially cool about this is that you can still filter on predicates for each of these orders. For example, I could say that I want to limit the orders I get for each status to only have one response. And as you can see, now I'm only getting one order for each status. So that's how you can perform a join from a function to a model, or in this case, to an array response of models. This relationship type could also be an object if the function's return was returning an individual order response rather than an array. Let's talk about how you can join a function to another function. And to do this, first we'll create a class called firstOutput that will be the response of our first function. And we'll just say that it has an attribute A that is a string. And then we will create our first query by using the register query decorator. And let's say define chain, and it returns first output. And let's just say return first output, and we'll say A equals first. And then let's define a second output type. And we'll say that this also has the attribute A, which is a string. It also has attribute B, which we'll say is a string. And we'll now register another query. and we will define, we'll call this one chained, and it takes as a parameter a, which is a string, and it returns the second output, and we'll say return second output, a equals a, b equals second, let's say. Now let's go to the terminal and perform introspection, DDN connector introspect Python. And when the introspection's done, we will run DDN connector link, add resources, Python. Now, before we do a supergraph build, let's add our relationships. So let's open up both chain.html and chain.html. And I'm actually going to split the terminals so that we can see both of them here. And we're going to scroll to the bottom of chain, and we're going to add our relationship now. Kind relationship, and in this case it will be to a command. The relationship name, we'll call it chain relationship. The source type is going to be chain result, which is the object type at the top of the chain.html file. And then the target command name is going to be chained because we're targeting the other command here, which is the chained command. And we're going to map the field A to the argument A. So essentially what we're doing here is we're saying we want to map the field A from this output onto the input A for this function and chain these functions together. So now we'll do a supergraph build with DDN supergraph build local. And we'll go to the console. And as you can see, now there is the app chain, which is our chain function. And there is a relationship, which we'll call the second function, the chain function. And when we call this, will give us back a as first, and then it will call the second function. And we can see that actually in the traces when we take a look, where we see that it will execute the first part of the query, and then it will go back to engine with the response, and then it will execute the second part of the query. In this video, you've learned how to join data to functions, functions to data, and functions to other functions. This wraps up our series on using the Hasura Python Lambda connector. I hope you enjoyed, and feel free to leave a comment and let the team at Hasura know what you plan to use it for. Happy building!